Almighty. Today's topic is framing related with data link layer. Also, we'll be explaining about binary synchronous communication protocol, point-to-point protocol, digital data communication message protocol, and HDLC. In data link layer, blocks of data called frames are exchanged between nodes. In network interface controller, NIC, also known as a network interface card, network adapter, another name is network adapter. You can see the network adapter in the figure. Network adapter or LAN adapter or physical network interface. These are the words used for different words used for this, or terms used for adapter, network adapter. A network interface card, network adapter or LAN adapter. It is a computer hardware component that connects a computer to a computer network. Network adapter enables the nodes, you can see here two nodes, node A and node B, to exchange frames. When node A wishes to transmit a frame to node B, it tells its adapter to transmit a frame from the node's memory. This results in a sequence of bits being sent over the link. The adapter on node B then collects together the sequence of bits arriving on the link and deposits the corresponding frame in node B's memory. Determining exactly where the frame begins and ends is a central challenge faced by the adapter. There are several ways to address the framing problem. We look into byte-oriented protocols. Byte-oriented protocols. In this approach, each frame is viewed as a collection of bytes or characters rather than a collection of bits. Such a byte-oriented approach is exemplified by the BISYNC protocol, called as binary synchronous communication protocol. Another byte-oriented protocol is DDCMP and PPP. DDCMP is digital data communication message protocol. PPP is point-to-point protocol. BISYNC protocol. We call that approach as a sentinel approach. What is a sentinel approach? The BISYNC protocol illustrates the sentinel approach to framing. What is that? Its frame format is shown in figure. The beginning of a frame is denoted by sending a special synchronization character SYN. The data portion of the frame is then contained between data portion or body. You can see body there in the figure. Body is contained between special sentinel characters STX, start of text, and ETX, end of text. These are sentinel characters. You can see SOH here, start of header. This field serves much the same purpose as the STX, start of text field. The problem with the sentinel approach of course, is that the ETX, end of text character, might appear in the data portion or the body portion of the frame. BISYNC overcomes the problem with the Sentinel approach. That is, ETX character might appear in the data portion or the body portion of the frame. BISYNC overcomes these problems by escaping the ETX character by preceding it with the data link escape character, DLE character, whenever it appears in the body of a frame. Data link escape character is also escaped by preceding it with an extra DLE in the frame body. This approach is often called character stuffing because extra characters are inserted in the data portion of the frame. The frame format also includes a field called CRC, cyclic redundancy check, that is used to detect transmission errors. Next byte-oriented protocol is PPP or point-to-point protocol. The most recent point-to-point protocol, which is commonly run over dial-up modem links, is similar to BISYNC in that it uses character stuffing. The format for a PPP frame is shown in figure. You can see here a special flag 0610, after that 6 ones, 1 2 3 4 5 6 ones are there, then 0. There is a flag field, the starting and at the end of a PPP protocol frame format. You can see a flag field. Flag is just like we are showing the flag, okay, like that. Here the flag field is 0, after that 6 ones and then 0. This flag field 0 6 1 0. It will be there in the starting and at the end of a at the ending of a PPP frame format. The flag field is 1 byte with a binary value 0 6 1 0. Then there is an address field. Address field is basically a broadcast address. What is the broadcast address? All can receive the data which we are sending. TV is suppose we are getting the news, that is a broadcast news, right? We all are receiving it. Just like that, here the address field is basically a broadcast address. Here the field consists of a 1 byte data which is having a value all ones, 1 1 1 1 1 1 1 1. PPP does not provide or assign an individual station address. Instead, it gives broadcast address. And there is a control field here. Control field in PPP, this field is set to 1 byte, that is 6 zeros followed by 2 ones. Binary value. This 1 byte is used for a connectionless data link. We know that there are connection oriented and connectionless data links. This 1 byte is used for connectionless data link. Then there is a protocol field. This field basically identifies the network protocol of the datagram. It usually identifies the kind of packet in the data field, which kind of data which we are using in that data field. When we are sending the data, what sort of data, what kind of data we are using. That is what exactly is being carried out in the data field. This field is of 1 or 2 bytes. Then comes the data field or the payload. That payload is usually that part that contains the upper layer datagram. Whatever there was in the upper layer, Just above the upper layer of data link layer is the network layer. Network layer datagram is particularly encapsulated or covered in this field for regular PPP data frames. Length of this field is not constant, rather it varies, payload varies. Then there is a checksum field. This field usually contains a checksum simply for identification of errors. It can be either 16 bits or 32 bits in size. Characters are added to frame for control and handling of errors. Starting and ending, we know that it is starting with a flag, and it is also in PPP format. We are ending it with a flag format. That's all. Next is the DDCMP approach. Digital Data Communication Message Protocol. It's a byte-oriented approach. In DDCMP, the count field, there is a field known as count field. You can see that. That represents how many bytes are contained in the frame body. The common error is the count field may be corrupted. It is called as framing error. Count field specifies how many bytes are contained in the frame body. So you can see here the DDCMP frame format. The count field specifies how many bytes are contained in the frame's body or data field. One danger with this approach is that a transmission error could corrupt the count field, in which case the end of the frame would not be correctly detected. If this happens, then the receiver will accumulate as many bytes as the bad count field indicates, and then use the error detection field to determine the frame as bad. The frame is bad. It will be saying that the frame is bad. This is sometimes called a framing error. The receiver will then wait until it sees the next sync or synchronous character to start collecting the bytes that make up the next frame. There are three classes for DDCMP frames. They are used for one is called as transparent class or maintenance message. Second class of DDCMP is data messages, and third class is control messages. And we can see a header field here. Usually header deals with control information such as addressing, where it is going, where the data should be moved. So such sort of addressing information is present in the header field. CRC is here, cyclic redundancy check, body, that is a data part, CRC for error detecting. Next approach is not byte oriented, it is bit oriented protocol called as HDLC, high level data link control protocol. Unlike the byte oriented protocols, a bit oriented protocol is not concerned with byte boundaries. It simply views the frame as a collection of bits, BITS. High level data link control protocol denotes both the beginning and the end of a frame with a distinguished bit sequence. 0 followed by 6 ones, then 0. This sequence is also transmitted during any times that the link is idle, so that the sender and receiver can keep their clocks synchronized. In this way, both protocols essentially use the sentinel approach. At times, this sequence, usually the start of a frame, HDLC frame, and the end of a frame is done with this 0610. This is a special sequence. This sequence can be a data also at times. because and at times this sequence might appear anywhere in the body or data part. So it should not be misunderstood that it is the end of the frame. For that, HDLC had provided one approach that we can see it. Inshallah. This sequence might appear anywhere in the body of the frame format. In fact, the bits 0610 might cross byte boundaries. Bit-oriented protocol uses the analogy of the DLE character, a technique known as bit stuffing. Bit stuffing in HDLC protocol works as follows. What is bit stuffing? In HDLC we are using bit stuffing. Suppose starting sequence is 0610 that we know. Ending sequence is 0610. Anywhere in the body, suppose that anywhere in the body, this sequence 0610 is the data. Actually, it is not the ending sequence. Suppose a data is coming in the form of 0610. It should not, it should consider that as a data only, 0610. We can see how HDLC format is going to look into that data. It will be using bit stuffing for identifying it is data. You can see what bit stuffing is. On the sending side, anytime 5 consecutive ones have been transmitted from the body of the message, that is excluding when the sender is trying to send the distinguished 0610 sequence. That is starting and the ending sequence is that one. When other than that in the body at any time 5 consecutive ones are coming, the sender inserts 0 before transmitting the next bit. 0610 is the ending sequence or starting sequence. So when suppose the same data, it is coming as same sequence is coming as a data part, the sender will be purposefully inserting a 0 before transmitting the next bit. That is 0 after 5 ones, it will be purposefully inserting a 0 before transmitting the next 10 bit. 5 consecutive ones, next bit will be if it is a data or body part, next bit will be 0 stuffed. So the receiver knows that after 5 consecutive ones a 0 will be coming, so the receiver will be discarding the 0 after the 5 consecutive ones. So it is clear that it is a stuffed 0 in order to distinguish that data part from the starting and the ending sequence. So instead of this 0 after 5 consecutive ones, a 1 is coming. That can be an indication that yes, it is going to, the data frame is about to end, or an error has been introduced in the bit stream. Look at the next bit. After in the body part, suppose it is after, if 0 comes after 0, then 6 ones, the body, if it is data, then after 5 ones, a 0 will be purposefully must have been included. Here 0, first starting bit is 0 followed by 6 ones, then 0. That gives an indication that is the end of the frame. And suppose if 0 followed by 6 ones, and it is not ending with the 0 again, and it's not the end of the sequence, but instead of that a 1 is present at as the last bit, then that is an error. Discards error. Discard the whole frame. The receiver needs to wait for next 0610 before it can start receiving again. Thereby we complete this topic of this day. Hope the topics are clear. May Almighty bless all of us to understand the basics of data link and on all the framing techniques. I believe that all our duties are sincere prayers. I'm humbly praying to Almighty to accept this duty of mine as a prayer, and I'm stopping my words here. Thank you. ربنا تقبل منا إنك أنت السميع العليم سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.